Hi, everybody. We're going to try this again. This is multiplying two binomials, the special cases, and I decided to redo this one. So here it is. Hopefully we can give you the right information and the right way to explain this one today. So let's just multiply two binomials. Now, most people are going to use the FOIL acronym, unfortunately. And I say unfortunately because I'm going to show you a different methodology. But for right now, we'll go ahead and take a look at it. Now, what we're looking for, of course, are patterns. But let's start out by just multiplying these binomials normally. So we multiply the r times the r. That's the firsts. That's r squared. And then we multiply the outer pair, which is minus 4r. And we multiply the inner pair, and that's plus 4r. And we multiply the lasts, which is positive 4 times negative 4, which is minus 16. Now, what you're going to see, of course, and hopefully notice, is that these are equal and opposite, and they give you 0. So we end up with what we call a difference of squares. This is going to be the first one squared minus the second one squared. And this is a difference of squares. This happens over and over again, and this is a pattern that you want to memorize. Now, what you need to be very, very careful of is that this is not the same as this. A very common mistake is to think that this will be equal to that. They are not equal. And this is what we're going to look at next. So perfect squares are different than a difference of squares. A difference of squares means if I take a plus b, no matter what a and b are, they can even be expressions with multiple variables, and I take a minus b and I multiply them together, I always get a squared minus b squared because the middle terms cancel out just like they did here. Okay, I know that's a lot of stuff, but don't worry, just be careful. This is not the same as that. This is r squared minus 16. Now, hopefully this one's going to be r square, and it is. Okay, so now we have what we call a square. This is going to be called a perfect square trinomial. And there's two things about perfect square trinomials that we always want to keep in mind. First of all, you cannot distribute that square. I know you think you can, but you can't. If that had a number in front of it, if I was multiplying by 2, I could distribute the 2 by multiplying it by both terms. But you cannot distribute a square. What you can do is we can rewrite it as 4f minus 2 times 4f minus 2. And I want you to notice that there's going to be two things that are going to happen here that are really important. The first thing is that, sure enough, just like we kind of expected, we're going to have 4f times 4f, which is 16f squared. And our outer pair is going to be minus 8f. And I want you to notice that if I multiply the two terms, the a and the b part together, I get negative 8f. Look at my inner pair, negative 8f. Again, notice that these are always going to be the same, no matter what, because you're squaring it. The last term I want you to notice is a negative times a negative. So there's two things that are always going to be true. You are always going to double the product to get your middle term. Double the product of the two parts of this. So if I take a plus b squared, or a minus b squared, same thing, I always get a squared plus double the product plus b squared. Notice that this will always be positive, even when the middle is negative, and the only change is going to be a negative here. So just a couple of things. We're looking for patterns, and the pattern in this case gives us our 16f squared minus 16f plus 4. And there it is. 16f squared minus 16f plus 4. And this has a name. This is called a perfect square trinomial. And the thing about perfect squares is that you always get a middle term and you always get a positive last term. You are going to be tempted to distribute that. You cannot do it. Don't even think about it. You must get a middle term and you must always get a final positive term. That's always the case. Okay, so let's just do some examples. I'm going to go fairly quickly this time. So look what I'm going to do. I'm going to square the first terms. Let me get rid of this first. So we get 4u squared, don't we? Now I'm going to multiply them together. That's 4u and double it. That's plus 8u. And then I'm going to have a plus 4. I want you to notice something. What I did, and I really is really important, is that I took the first part and squared it. So I took the 2u and I squared it. Then I added twice the product of the 2 times the 2u, which is 4u. Notice that I had to double it because I got 2 of them. And finally, I squared the last term, which was the 2 squared, which gave me the 4. So there you have it. Hopefully it's clear. We're going to do lots more, and I'm going to go fairly quickly. Now this time we have a difference of squares. The middle terms cancel out. Lots of ways of looking at it. Minus 4a plus 4a is 0. So I only get the a squared minus 16. That's it. It's that easy, I promise. Z squared minus 4. I square the first, subtract the square of the second. It has to have the pattern, though. They have to be equal, though. A plus B times A minus B. We get, let's put this in, Z squared minus, and 4 in this case, A squared minus B squared. Okay, this is not Z squared minus 4. This one is a perfect square trinomial. And remember, we are going to get Z minus 2 minus 2 times Z minus 2. And we're going to end up with the first term. Let me get rid of this thing. The first term is going to be the Z squared. Then we're going to double the product. The product is negative 2Z. Double that. That's negative 4Z. Oh, I better give it a space just in case. And the last is always positive. That's another mistake that a lot of people want to make. So it's going to be plus the square. So it's going to be plus 4. A negative 2 times a negative 2 is a positive 4. Notice negative 2z and minus 2z makes negative 4z. That's our middle term. Okay. This is going to be 4b squared minus 1. We're just going to take a minus b times a plus b. I know the b's are in front this time, but anyway. 4b squared minus 1. 1 squared is 1, isn't it? So be careful. Now this time, remember, we are talking about a perfect square trinomial. There's a square always has a middle term. Don't forget, you cannot distribute the square. You're going to be tempted to. I promise, everybody's tempted. 9w squared Now our middle term is going to be double the product. The product is multiply the two terms. Negative 4 times 3w is negative 12w, but you have to double it because you get two of them. That's negative 24w. Make sure I put a space in here just to space it out a little bit. And the last term is always plus the square, so it's plus 16, isn't it? And there's our trinomial. This thing is called a perfect square trinomial. And there's something you're going to be doing soon, and that is completing the square. For example, just to show you where this is going, you want to learn this pattern because you're going to be given something like this, say x squared minus 6x. And they're going to ask you, what number will make this thing a perfect square trinomial? Well, we know that we got the middle by doubling the product. So x minus 3 times x minus 3 must have been what I squared to get this. What's missing is the plus 9. The reason we're learning this pattern is so that we can do this, which is called completing a square. That's one of the things that we're going to. There are other reasons for learning what perfect square trinomials look like. Anyway, there it is. All right, so here's another one. So this one is going to be, let me get rid of this thing, darn it. Let me get rid of that, there we go. Okay, so we have 16, j squared, and our middle term is going to be the product, which is 4j, doubled, 8j. That's plus 8j. And we get a plus 1 at the end, don't we? That's it. It's that easy. Just look for the pattern. This is a difference of squares, n squared minus 1. Let's see, what do we got here? We have difference of squares. 16m squared. We have a minus, and then we have a 16. 4 times 4 is 16. We're squaring it. Don't distribute the square. That's 9b squared. Our middle term, remember, is double the product. You can take the product, don't add them. It's negative 9b is the product, but you have to double that. So it's minus 18b, isn't it? And the last term is plus 9, not 6. Negative 3 times negative 3 is plus 9. Remember, there's always a plus on that last term when you square. That's a perfect square trinomial. All right, difference of squares. We've got 9a squared. And it's minus, always minus in the middle, and then a 4. That's it. Difference of squares. This one is a perfect square trinomial. These are the kind we really like, k squared. Our middle term is plus double the product, which is going to be 6k. 3k doubled is 6k, and then plus the 9. This one is going to be a difference of squares because it's a minus b times a plus b. That is 9m squared. Be careful, that is a 9. And we have a minus 1, don't we? Have to take a difference of squares. This one is going to be a perfect square trinomial. That is s squared. Our middle, darn it, our middle term is going to be plus. We're going to double the product. 2s doubled is 4s. And then we have a plus 4, of course. This one is going to be a difference of squares. That's going to be 4c squared. And it's going to be a minus. And we have a single term, 4. 2 squared is 4. A squared minus b squared. This one is going to be a perfect square trinomial. We get b squared. Our middle term is double the product, not 4, double, 8b, isn't it? Plus 16. We're not adding the 4s, we're multiplying them. Okay, perfect square trinomial. We get 9j squared. Our middle term is going to be double the product. The product is negative 6j, so double that is going to be negative 12j. Oh, I need a space, don't I? There we go. And our last term is the plus 4. Remember, always double the middle term, and it's always going to give you a middle term. Be careful. We're getting there. Okay, we've got w squared minus 1. Difference of squares. There it is. This one is going to be a difference of squares. 4q squared minus the 4, huh? Come on. There we go. And what about this one? We've got a perfect square trinomial. You don't distribute the square. That is 16r squared. We always get a middle term. It's going to be, oops. The middle term is going to be double the product. The product is negative 16r, but double that is negative 32r, isn't it? God, I keep forgetting to put that space in there. I'm afraid that it's going to count it wrong. And the last term, of course, is the negative 4 times negative 4, which is the plus 16. We want to learn the pattern. You don't want to always just rewrite it every time. And you certainly don't want to distribute the square. Hint, hint, hint. I'm going to keep harping on that. Okay, so we've got 16f squared. We have a middle term. Our product is negative 12f. So double that is going to be negative 24f, isn't it? And our last term is going to be negative 3 times negative 3, which is not 6, it's positive 9. Remember, that last term is always going to be positive for perfect squares. Not difference of squares. Difference of squares is something else. This one is going to be a difference of squares, which is 4r squared minus 16, isn't it? 4 times 4 is 16. Couple more. Looks like it's a perfect square trinomial. We've got 4d squared. Our product is negative 4d, so our middle term is going to be double that, negative 8d. And I seriously need to remember to put my space. Plus 4. Because remember, we multiply a negative 2 times a negative 2, which is positive 4. 2 more. Difference of squares. We've got 16q squared space minus space. Oh. Minus space 16q squared minus 9, a difference of squares. It's just a pattern. Maybe 2 more. Okay, perfect square trinomial. Y squared minus 2y. And the last term is plus 1, isn't it? And this one is our last one. And it is a nice, easy one. U squared minus 9. I hope you guys will try it yourself. Learn your patterns. U squared minus 9. And we have a difference of squares. Practice, 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 and get your mastery. I'll see you back again. Bye-bye.